Let's take a look at some local atom monitoring techniques and considerations and review a sampling of third-party tools. The next two slides review some operational monitoring best practices. Regarding the server, if you have a local atom, we suggest having some basic monitoring on the server that is running the atom. That would allow you to establish a baseline for the processor and RAM usage. When considering atom availability, you want to monitor the general status. This can be done by subscribing to the email alerts with atom.status as the type, and by reviewing the container.log file with a tool like Splunk to identify problems. To measure the internal health of the atom, you can use JMX compliant monitoring tools to connect to the JVM. And we will take a closer look at this in some following slides. For general execution health in the process library on the platform, there is a sample heartbeat process to verify the process is actually executing and pinging the application endpoints. And let's just take a quick look at that heartbeat process available to you. So in the platform, you click on Browse Process Library, and you can search on heartbeat, and you can choose a place to install this process. Once the process is installed, you can click on the Atom Heartbeat Monitor, and you can find more information for this by following this link. And you'll find instructions on how to create a heartbeat process for Atom runtime monitoring. And one last consideration here, if you have a molecule or private atom cloud, the JMX properties can run on each node JVM. You can also monitor the container.log files on each node, which can give you insight into cluster communication. Let's take a look at some third-party tools as well and how they can help you out. Visual VM is a tool that provides a visual interface for viewing detailed information about the Java applications while they are running on a JVM. We saw that Java Visual VM is a graphical user interface that provides detailed information about a JVM. And so to configure Visual VM with your Atom, you must enable JMX on the atom.vm options file. Visual VM is available in a Java JDK. If it is not currently installed on the server, then you will need to download and install. When you run the .exe, you will have options to configure the tool to monitor the JMX connection. There's a user guide article to walk through these steps in the user guide, as well as a helpful community article. Let's take a look at both of those. So when you're on the platform, you can navigate to the user guide and search on Visual VM. And you can find easily the Configuring Java Visual VM for JMX management. Likewise, you can click on Community and search for Install Visual VM. And you can find that there are several helpful articles here available for you to install and configure Visual VM. There are other third-party tools that can help in runtime monitoring. Foglight is a performance monitoring solution which maximizes the performance and availability of applications and databases while simplifying management. Zabbix is an enterprise-level software designed for real-time monitoring of millions of metrics. This is a free open-source product. And Datadog is a monitoring service for cloud-scale applications. It lets you see granular metrics from your entire stack, from application level to your actual hosts and VMs. It brings together data from servers, database tools, and services to present a unified view of the entire stack. And these capabilities are provided on a SaaS-based data analytics platform. Now we're going to take a look at runtime monitoring. The field names are specific to Zabbix, but other JMX monitoring tools will be able to display similar information as well. First is a general atom status field. This will allow you to see if the atom is stopped, updated, or running. The status should be running most of the time. Next, it's a good idea to monitor schedule on the atom because having multiple processes scheduled at the same time can constrain the atom resources. Also, if the scheduler misses a schedule, then there could be timing issues with the server. Within a molecule or private atom cloud, it is important to monitor the clustering and communication between the nodes. Some issues will cause the molecule to go offline, so having monitoring will help with troubleshooting. We talked earlier about heap allocation, but JVM will not always use the full allocation, and if the JVM does reach the full allocation over long periods of time, you may consider adding more heap space or additional resources to the server. Monitoring the thread count will give you a point in time for anomalies or slowness in the process. JVM uptime and CPU time are indicators of past issues to give a point in time. Garbage collection count is an indicator that the garbage collection is on.